Okay, this is part two of solving exponential equations. Um, in this video, we're going to look at example C and D, and we're going to use two different strategies. Both are types of factoring. The first one is common factoring, and the second will be a quadratic factoring example. How is example C different from A and B? Well, in example A and B, we had a single term on both sides of the equal sign that if we were able to change the bases, we could then equate the exponents. In example C, we don't have that. We have two terms on the left side, both with an x, and one term on the right side. If we could use some algebra here and modify the way the equation looks to get it to two terms, one on the left side, one on the right side, then we could use similar strategies to examples A and B. But that will take a little bit of work. And the strategy we use is common factoring. Why common factoring? Well, if we look at the first two terms on the left side here, 3 to the exponent x plus 2 and 3 to the exponent x, they do have 3 to the exponent x in common. How do they have 3 to the exponent x in common? Well, if we look at the first term, 3 to the exponent x plus 2, we can rewrite that using exponent rules in reverse. So the exponent rule that I'm talking about here is when you're multiplying powers, you add the exponents. So in this case, we have two exponents being added, a single exponent with two terms being added. We can break that back into two powers being multiplied by rewriting this as 3 to the exponent x times 3 to the exponent 2. And now, as you can see, if you were to multiply those powers, you would add the exponents and end up back where we started. Why do we do this? Well, I'm just going to write the rest of the equation here, minus 3 to the exponent x equals 216. We do this because now we have something common to these two terms, 3 to the exponent x. And if we common factor 3 to the exponent x from these two terms, we're left with 3 squared, which is 9, and negative 3 to the exponent x divided by 3 to the exponent x would leave us with negative 1. And 9 minus 1 is 8. So now we have 3 to the exponent x times 8 equals 216. Well, if we divide both sides by 8, we have 3 to the exponent x, and 216 divided by 8 is 27. Now we're back in the scenario we were in examples A and B. We have two terms, one on the left side, one on the right side, and the strategy we can now use is to create a common base, because 27 can be written as 3 to the exponent 3. Our left side is 3 to the exponent x. We have a common base. We can equate the exponents. X equals 3. And that's the solution to our equation. In example D, we have very similar situation to example C, except we don't have two terms being added in the one exponent. We actually have two terms being multiplied. And if we use exponent rules backwards in this case, we could write this as 3 to the exponent x squared. Because if we multiply exponents, we would end up with 3 to the exponent 2x. And I'm just going to write the rest of the equation down here. Minus 6, 3 to the exponent x, minus 27 equals 0. In this example, we used common factoring because we could, common factoring. Because we could common factor that 3 to the exponent x term. In this case, if we were to common factor the 3 to the exponent x term from the first two terms, we'd still be left with a second term with 3 to the exponent x because we have 3 to the exponent x squared. And common factoring isn't going to take that 3 to the exponent x and isolate it. So we need a different strategy here. And the strategy we're actually going to use in this case is factoring a quadratic. Why factoring a quadratic? Well, if we look at the way the equation set quadratic. If we look at the way the equation sets up, we have 3 to the exponent x squared, 3 to the exponent x, and a constant term. If we were to do a variable replacement, let's say let a equal 3 to the exponent x, it might be easier for you to see why this is quadratic. So instead of 3 to the exponent x, I'm going to write a. This would give us a squared minus 6a minus 27 equals 0. And now you can see pretty clearly that that is a quadratic. It's a simple trinomial that we can factor by looking for numbers that multiply to negative 27 and add to negative 6. The numbers that multiply to negative 27 and add to negative 6 would be negative 9 and positive 3. So that would give us a minus 9 times a plus 3 equals 0. Why are we factoring at all? The reason why we factor is because that's how we solve a quadratic. Because if we are factoring and our right side is 0, any of these brackets equaling 0 would make the whole expression equal 0. So even in exponentials, when we end up with a quadratic, the goal is to factor. So we can look for what would make each of these factors 0. But what is a? A is 3 to the exponent x. So if we look at these two brackets again, sorry, I'm just going to adjust my page here. If we look at these two brackets again, it's not a minus 9. Well, it is a minus 9, but it's actually 3 to the exponent x minus 9. And we want to make that equal 0. So we want to take our, I'm going to rewrite this as 3 to the exponent x minus 9 equals 0. So we want to figure out what x value, if we raise 3 to, gives us 9, because 9 minus 9 would be 0. And that might be easy for you to see that x equals 2 in that case, because 3 to the exponent 2 is 9. If not, rewrite 3 as a power with a base of 3, and that'd be 3 to the exponent 2, and then equate the exponents, and x equals 2 in that case. So one of the solutions to this quite complicated exponential function is x equals 2. The second solution is if we change a back to 3 to the exponent x plus 3 equals 0. We want to move the 3 to the other side and say negative 3. So 3 to the exponent x equals negative 3. What value can we raise 3 to give us negative 3? There isn't one. There's no solution from that. And if you think about what an exponential function looks like on a graph, it has your horizontal asymptote at y equals 0. Therefore, there's no negative y values. So there's no value of x that we can put in to this power to get a negative value, specifically negative 3. So the only solution in this case is x equals 2. So that's factoring a quadratic exponential function and using common factoring to solve an exponential equation.